Hello guys, I think I am live now. Wait, I will check and let's continue. So, yeah, I think I am live now. Mhm. Hello guys, am I audible? Hello guys, am I audible? Yeah, so let's start. It's working fine, everything. So today is the basically day 4 of machine learning, and today I am going to explain you about the decision tree. So let's start today lecture, and here we are. Here is my functions machine learning playlist is there, decision tree. Okay, so let's start decision tree. Okay, decision tree is basically, I can say, the best part in interview. This they can ask you about a decision tree many question in many form. Like decision tree is the very important topics, we can say that. Okay, so let's start the decision tree algorithm. So basically you can solve regression and classification problem using decision tree. So the decision tree looks like this. You can see, we can see that by a branching. Basically decision tree is nothing but basically it's a if else loop. So if suppose you have created a function where age is less than equal to 15, if this is yes, then person is in school, and no if the less is less than 15, if then he's like not in going to school, something like that. You have to create a function like that. Age is greater than 15 and age is less than equal to 15, something like that. You have to basically, it's decision tree is nothing but it's a if else loop, and it is not based on distance. That's it. So if it is not based on distance, then there is no need of we can say a feature, like we done a feature, we can say uh, standardization normalization. So in decision tree the standardization and normalization is not required. So then that's it. And for to find the accuracy of a decision tree, like we can get accuracy, and for that basically the question arises like which, like suppose you have a features like 10 features, so then which features we have to start the splitting. This is the question. Like if you have a 10 features, then which feature is the best feature to split this tree? If you not select a best feature, then your decision tree will be a very long. So to find like which features we have to start splitting the decision tree, so there are two three types of algorithm. Like uh, we can say first one is entropy and the second one is information gain, not yeah, information gain, we can say. So firstly is entropy also known as randomness, and the second one is Gini index basically. And let's see the formula of entropy and Gini index. And the second one is information gain, so feature to select for decision tree construction. So information gain is also used to like which features we have to select. So let's see like how this entropy and Gini index and information will work. Okay, so to split our decision tree, first let's see entropy. So the formula of entropy is basically minus summation of p log p. P basically the probability, we can say that. So suppose this is the formula of entropy. H of s is equal to minus p log p minus p minus log p minus. This is basically p positive and like probability of positive class and probability of negative class. Suppose you have divided this data into three classes. Then here you have to find like for finding the probability of suppose if you divide your data by outlook, then what is the entropy you have to find out. To find out the entropy, this is the formula. And so by putting this value, like suppose you have split this data something like that, feature 1, feature 2, feature 3 is there classes, and 3s3 no, then you have to find like put these values in like positive class is 3s, and like what is the probability of 3 no, and so you will get the same probability, so which is equal to 1. This is a impure split. Pure, if you get a pure split, then this is the fine, like here you can see 3 yes and 0 no, so further split is not required after this step. So basically your aim is to find the pure split. If you get a pure split, then this is the fine split. And the second one is Gini impurity. Gini impurity is basically 1 minus probability or summation of probability ka square. So that's it. So for entropy, you can see that a graph will be ranging between 0 to 1, and for Gini impurity, it's graph between 0 to 0 0.5. Now, coming to the point like, so Gini impurity, this is the formula. You can find out the, if you are a pure split, then this is 0, and impure split, the maximum ranges from 0 0.5. And now comes to information gain. Let's go to information gain after some time. Basically, firstly we will discuss like we have learned like entropy and Gini impurity. What, which is best, entropy or Gini impurity? So here you can see that in the formula of entropy you can see log, but in impurity, Gini impurity, only the probability p plus and p minus is there. So the time complexity in case of entropy is very high because you have to solve a log equation, and log of something 10 something you have to calculate. But in Gini impurity there is no formula log, for log is there, you have to only calculate like 1 minus 1 by 2 k square plus 1 by 2 square. It's very simple equation. So if your data set has a very huge data, like suppose 1 lakh data, like if your data size is very high huge, then directly apply Gini impurity. Gini impurity does not give a good accuracy, but still you can use because it is not like same, but it is not good than entropy, but still you can use it Gini impurity, because if you apply entropy in very huge data, then it will take very huge time. So that's it recommended to, if your data size is small, directly use entropy, but if your data size is very high, then use Gini impurity. So that's it for entropy and Gini impurity. Now coming to the information gain. So basically information gain is basically used to find the split. Basic information gain, like entropy. Basically entropy means randomness. So randomness, you have to, if you find a randomness according to first feature, second feature. If suppose your data set has a 100 feature, and you have to find entropy for different feature every time. For 100 features you have to find the entropy. So if the entropy is coming very low, entropy means basically randomness. So you want randomness, minimum randomness in your data set. So in the case of entropy, you have to find the minimum randomness. So which features give a minimum randomness, you have to select that feature to split this data set. But in case of information gain means gain. The gain you will get high, you will have to split on that feature. The name suggests like information gain, like which feature giving you information more, then you have to select on that feature. So suppose you have to this is the formula, like entropy minus s of v by total of s into h of s of v. H of s of v, like this is the entropy of that feature. Suppose you have splitting from f1, so entropy of f1 minus summation of entropy, like probability of s upon probability of total, like s of v upon s, and to multiply with probability, like h of s of v means randomness or entropy of this feature, not feature, this is basically a c1 category 1, or we can say that our C2 category, not we say features, not basically a split, we can say that. And for C2 also we have to calculate all of these things, and then you will get some values. So whichever feature you will get information gain high, you have to select that feature. So here you can see that this is also a very complex equation. If you get a very huge data, then don't apply information gain, directly apply gain impurity. But if your data size is small, then directly apply information gain. It will take time, but your data set is not high very huge, so you will get a answer in a minimum time, and a very good answer you can get it. So this is the formula to find the gain of S of F1. So 0.94 is the entropy of feature 1, and minus probable S by S of V by total number of S basically. So in here is 8, like 6 plus 2 8 by total number of features, like 6 plus 8 of 14. So you will get 8 by 14 into entropy of feature c1 into plus same as the formula, you can apply it. So you will get a gain of s of f1, and this, like here, the idea will comes in your mind. Mhm. Okay, so like entropy versus gain imperative, which one I have to apply? So I already tell that the entropy formula is taking very huge time. So if your data set is small size, you can directly apply entropy. If your data set is very huge, then apply gain impurity, because in gain impurity the log formula is not there, so you will get answer in minimal time. That's it, like whenever data is small, apply entropy, large data set, gain impurity. Now coming to decision tree regression. Okay, so let's continue our discussion on decision tree regression. So the idea is that gain of HOV. So in case of regression, basically, firstly, what we have done in case of classification, we have to find the entropy and information gain according to this. But in case of regression, basically, we take the average between 40k plus summation of all these values, and that where you will get some value in between 40 and 42k. Then find the entropy according to this, and then you will get some value. And in the second time take 40 and take 40 and 42 in one class, and in the other values in the second class, and take again average, and then apply again this entropy, and you will get again a second answer, and then find the entropy information, then apply again and again, again and again, and you will get some value from where we have to split it. So that's we have to do. Firstly, if you get some, like in real life you will not get like this value in that format, so you will get some random value. So firstly you have to apply ascending or descending order, and then apply this, like take average and then again average, something like that you have to apply. So that's it in for regression and variance route. This is the like same. So in that case basically, to find the error, basically this is the formula for variance, like by minus by mean square divided by 1 by n. This is the simple variance reduction formula is there. Numerical value feature, we have already talked about this, or the feature value. Now coming to random forest classification and regression. So wait some time, wait 1 minute. Let's continue after some times. So I think everybody knows that the Devon AI will came, and everybody today is now everybody is shocking, like what if the Devon AI will able to write a code which will be a good like perfect than me like humans, then what will happen? So basically this is the time where we have to learn many more things, but nobody can't predict it, because due to coming of ChatGPT we are now seeing very huge recession is going on, and everybody is now losing job because of rise of AI and ChatGPT. Suppose if this Devlin AI will able to write a code which is good than human, then this is the very bad situation in market we are seeing now. So now let's continue our discussion on decision tree. So we are now discussing on random forest classification and regression. So we know that random forest is nothing but a collection of many decision tree, or we can say a big learners. So basically there is a two types of ensemble techniques. One is bagging and boosting. We will learn the boosting after some time. So basically the random forest comes in the category of bagging. So what we have done in bagging, basically in bagging we will train all of these big learner in a parallel manner basically. So suppose you have a data set of 1000 rows. So we will give 100 of features to first M1 model, and then again randomly shuffle this data, and again take 100 samples of data set and give to the second model, and again continuously we will give, basically we will give hundred of thousands of model basically we will train, and then find predict, they will predict some output according to this data. and then after that we will take majority votes. Basically, suppose here three models are giving zero answer and one model is giving one answer, then we will take a majority vote and give say that zero is the right answer. Basically, in that random forest is done. And for regression, basically we will predicted some output and then we will take the average of that all of this model. So for this was done. And for basically what happen in decision tree, if you will train a decision tree, you will get a overfitting model, because decision tree is nothing but a if else loop. So this will train on a training data set, so you will get a overfitting model. And overfitting also known as low bias high variance. Low bias means basically your training data have a high accuracy, but in when you go to a production level, you will get a low accuracy. So low accuracy means testing low accuracy means high variance. So what random forest will do? Basically, random forest is basically a combination of decision tree. You will get different decision tree, and if you will get different decision tree, and if you apply like this majority votes in the output, you will get a generalized answer, because you have trained different model in a different data set. So you will get a good accuracy in that time. So basically the aim of random forest is to basically convert your overfitting model into a generalized model, but generalized model will have low bias and low variance basically. This is the idea. Now coming to ADA boost machine learning algorithm. ADA boost basically this comes in also inside a decision tree. Like there's a two types of machine learning algorithm, bagging and boosting. In bagging, basically random forest classifier and random forest regressor will come, but inside of boosting they add a boost, gradient boost, xg boost algorithm will come. So basically this is a big learners decision tree we will train in that type of decision, in that type of ensemble learning techniques. Add a boost is basically a boosting algorithm where we will train our algorithms in a sequential manner. We will see it after some time. The aim is also same, like in decision tree you will get a overfitting model, so you want a generalized model, so you will get a generalized model by applying a boosting algorithm basically. Low bias high variance. So in boosting, basically we will train all of these big learners in a sequential manner. So suppose again what we have done, we will train these big learners in data. Basically we will train dt1 data set 1, randomly take a data from data set 1 and train on this model. And the second time we will give the second data to this second model big learner in a sequential manner. But in the second time we will also give the wrongly predicted data which was wrongly predicted by this big learner. We will give this data also to our decision tree second, and also randomly shuffle data and give higher weightage to this wrongly classified data which was predicted wrongly by the previous model. We will give higher weightage to this, basically we can say a high weightage to this wrongly classified data. And that's it for continue until we will not get good accuracy. So by combining all of these learners we will get a strong learner. So that's for like in boosting algorithm we will done. So now comes in mind like which model we have to apply, like bagging or boosting, like random forest or this one xg boost ada boost algorithm we have to apply. So the same, like if you get a small data set, apply directly random forest, because in random forest you will train the model in a sequential manner, no, in a parallel manner. But in boosting algorithms, we have to train this model in a sequential manner. So this will take very huge time. So that's why we have to apply ada boost and algorithm, boosting algorithm if your data set is very like complex and small data set. So that's we have to do, like giving weightage and classification regression, like big learners already said that. Add a boost classifier method, we will learn it after some other video. Basically that we will learn it after some video, other videos, or we can learn it. Okay, we will start. Add a boost. So in add a boost, suppose we create a decision tree. Firstly, apply directly a decision tree and calculate a entropy. And the second time, basically in boosting algorithm, in the first model we will give same weight to every prediction, like s- to every prediction, not every prediction, we say that every training data we will give same weightage to this model and find the accuracy. So the performance formula is basically 1 by 2 log of 1 minus total error by total error. So you will get some error like performance. But in the second model, cell, now first model is train big learner. Now you have to train the second model in a sequential manner. So in the second time, we have to give higher weightage to the wrongly classified data basically. Suppose this is the data point that your model predicted wrongly. So in the second time, basically we will give higher weightage to this model. How we will give? So basically we have to take 1 by 7, 1 by 7, 1 by 7, you will get some answer. And then basically this is randomly we have given, but we have to give some equal weightage. So in the second time we will basically normalize these weights. So by normalizing this weight we will get the sum equal to 1, approximately equal to 1, not equal to 1 or equal to 1. So and then you have to create a bucket of that for that. So that here you can see that the bucket size of this wrongly classified data you will get 50% bucket, and for every you have given 0 0.008, 0 0.08, something like that. So the chances of giving this wrongly classified data to the second model is very high, because the 50% probability, like 50% time, like how you are giving this data to your second model. So that's how we are giving higher weightage to this wrongly classified data. And for this rate, so data boosting we have done, like giving higher weightage. So final prediction we can see that firstly giving data set to a big learner one, and for this model there's some alpha, like this is basically a hyperparameters. We have to change it after some number of epochs. We have to, every time we have to update these values. So for data set 1, and for the second data set we will give other data set and also give the wrongly classified data and give higher weightage to this wrongly classified data. Listen again what I am saying. Firstly we will give data, like randomly take 10% of data and give to this our big learner 1, and this will predicted some values, and suppose this will give 10% of data wrongly classified. So what we have done, we will give this 10% data to this second model, and 90% of data we will take it from randomly to this data set and give higher weightage to this wrongly classified data, which will predict, like wrongly classified from data set 1, we will give higher weightage to this data, like this is the wrongly classified. So now focus on more on this data set, like this we will give, we will tell us to this upper model. Now at a boost, gradient boost is done. Now gradient boosting algorithm is also is there. We will, let's see this in second lecture after some time. So I think I have done gradient boosting regression classification. This is also same like ADA boosting. Here learning rate is also there. XGBoost also we will learn in the next lecture. Let's continue XGBoost regression ML algorithm. Principal component analysis. Let's see PCA algorithm. So let's continue our discussion on PCA, principal component analysis. Why principal component analysis is basically required. So let's talk on PCA. Suppose you have a thousand of columns in your dataset, or we can say a features in your dataset. So in your dataset, thousand features are there, but 50 features, suppose out of 1500 features have correlation. Correlation means if f1 is increasing, then f10 is also increasing, and the correlation between f1 and f10 is suppose more than 90%. Then what is the use of that? Like, if it is already the correlation is very high, then this is not required, recommended. So that's here basically PCA will comes in picture. Suppose you have a M1 model and you have given only three features, then you will get some accuracy. And in the second time you have given six features to the same model and you will give some accuracy. So the accuracy in the second model will be higher than M1 model because you have increased the number of features. But in third time again you have increased, then again the accuracy will increases somewhat. But suppose if you now increase 50 features, so now this time will accuracy not increase, it will be decrease. Now the question will arises why. Wait, I will let you know why. And again F1 model you have given 100 features, the accuracy again will down, and the 6 model again will down if you give 5500 features. So now the question arises why this is decreasing. This is the question. So suppose you are a person who knows about house pricing. If the suppose you know that you are expert in house pricing, you know if the number of room will increase, the price will go increase. And the location is, suppose the location is also dependent on the price. If the location is very high, like in a very good places, like if you want to buy a house in Bangalore, the price will also automatically will increases. Now suppose again, if you want to buy a house, if there is also a feature like if you want to buy a house with near to celebrity, then it's also the price will go high. That's the reason. Now again, This is are some features. Now suppose I am asking about I want this and I am giving you 50 features, like I want this, then you at a time will came after 20-30 features, you will be some confusing, like this want this, then you can't remember all of these things. And so here you will get some confused at a time, like he want this. So that's the same problem will be in model. If you increase the features from somewhat, then it will be able to remember. But suppose if you have increased the number of features with 50, 60, 100,000, then how this model will be able to remember? So here the PCA comes in picture. So basically also known as cause of dimensionality reduction. Basically we can say dimensionality reduction. So dimensionality reduction is done by two formulas. First PCA, principal component analysis, and the second one is feature selection, also known as dimensionality reduction. So basically in feature selection what we have done directly, first one, now let's continue discussion on feature selection and then we will discuss on PCA. So now let's continue our discussion. So like how feature selection is done. Suppose you are doing feature selection for, if you have a dataset with 100 of features, then directly apply a covariance, comat variance, or we can say that a like covariance, or we can say that a variance matrix is there. Feature selection is covariance and basically Pearson correlation coefficient. Yeah. So you have to find a correlation coefficient basically. If you get a correlation coefficient greater than 0.9, 0.9 means basically you are getting a correlation greater than 90%. So that is not required. They're like, they are very highly correlated features. So apply firstly correlation coefficient in your data set, or we can say that a covariance correlation coefficient, like here firstly covariance of x comma y, the formula is this summation of xi minus x bar means basically mean into bi minus bi bar basically mean upon n minus 1. N is basically number of total number of rows in your data set, n minus 1. So you will get a covariance, and covariance of x comma y upon standard deviation of x into standard deviation of, or standard, no, it's a variance of x into variance of y, you will get a Pearson correlation. So if you get a correlation between greater than 90%, directly remove all of these features. So now you will get some highly features that are required in your data set only. So that's how we have done a feature selection. Now coming to the PCA, principal component analysis. So in PCA basically what we have done, in PCA, principal component analysis, our aim is to reduce the dimension of our data. Suppose if you have a data set of 100 features, so basically 100 feature means 100 dimension basically. So your aim is to convert in a minimum dimension in your data set. Minimum dimension basically means a dimension that you can, like human can see only 3 dimensions. So your aim is to convert in a minimum dimension so that you can visualize in a very good manner. So feature extraction I have already done, like feature selection is also known as like room size, room number. Remove this column if that is not required. In PCA intuition basically, suppose this is, you have a data set of 2 dimension, like this is the size of a room and this is the number of rooms. So basically in PCA basically we will what we can say that uh, spread, or we can say that we will loss of income feature extraction, what the name we can say, we will basically on this data we will put on this line like on x-axis. Basically take up basically projection, we can say take a projection of this number of rooms on a size. So you will get some values, or here you can see that this is the spread of variance of this size, but here you can see you have a spread of this in your number of rooms, but after projecting you will get variance in y-axis only, this one very low. So here you are losing very much information, like loss of information in number of rooms if you do 2D to 1D. So we want something else, so hey, something else means so that our like information gain will be, information lose of information will be less. So how this can be done? So this can be done by PCA, principal component analysis. So basically PCA will help us to minimize this loss. How? So basically now what we have done, we will take some projection of this vector in some another dimension. Suppose this is the x and y, we will take a projection on x and y coordinate in between, and then here you can see that this is the variance, and this is the variance of rooms, and this is the variance of number of rooms, and this is the variance on size. So now here you get some variance, still you will lose some information, but still you have some information, some variance of number of rooms other than here you can see that, but in that in PCA you will get some, like how PCA is done. So now eigen decomposition is done. Wait. So to find the PCA we will do eigen decomposition on matrix. So how eigen decomposition is done? So there's some transformation is done. You have learned, I think, in algebra. There's some eigenvalue decomposition is doing. That's the same thing here we have to do in PCA. Suppose you have a 10 features, and so basically your aim is to find the best line where you will get high variance basically. So you have to project all of these points in some direction, and then you will get some values on that projected line. So the line where you will get higher projection, that is the right line. So to find this line basically we apply PC algorithm, and to find this to apply this PC algorithm basically we have applied some transformation, like this is the math intuition behind PC algorithm. So let's see how this can be done. So this you have learned, I think, in 12th or some algebra, I think, the projection. To find the projection of any vector, this is the dot product of that vector into dot product of on which vector you have to find this like projection. So like P1 is there, like you have to find the projection of P1 into on X. So you have to apply do dot product and divide by on that mode of that vector, like do a dot product of like you have to find a projection of P1 on U1. So do dot product of that and divided by the mode of like take a modulus or big magnitude of that model on that projection that you are doing, like on that model. So basically here we will say the mode or magnitude of that on the vector that you are taking the projection is equal to 1. Basically it's a unit vector. So it's equal to 1. So you will get something equation like projection of P1 on U, it's equal to P1 into U. Like basically it's a scalar product, or because they are dot product only. So this is the max variance you will get to find the variance. And now eigenvector and eigenvalues. Now how to find eigenvalues and eigenvector? So you will get some columns in your data set, like thousand or hundreds of columns. If you have, apply a linear transformation and find these eigenvalues. According to eigenvalues, you will get eigenvectors. I will not go how to find, like how to find eigenvalues and eigenvectors. Learn it from any YouTube videos. You will get, if you, I will tell you, it will take some 1 hours to learn how to find this. So what we have to do, firstly find these, you will get some vectors and then find eigenvalues. According to eigenvalues, you will find an eigenvector. So, and then for that eigenvectors, you have to find the magnitude of that eigenvectors. So the magnitude on that vector, on that eigenvalues, if you are getting higher magnitude, this is your the best perfect line, or we can say the best perfect eigenvalue. So basically your aim is to find the eigenvalue where you will get higher magnitude. So eigenvalues basically. Suppose here we have, if you want to convert 3D data into 2D, so you will get some lambda 1, lambda 2. Basically this is the eigenvalues. So according to eigenvalues, you to apply this done into Bundy, and Bundy you will get a 2D. Suppose if you want to convert your 3D data into Bundy, you will get some 3 eigenvalues and apply some linear transformation, then you will get a Bundy equation. Your aim is basically to find the maximum variance. So to find the maximum variance, you will get it by applying this some linear transformation. So that's it for linear regression. We can say that a PCA. So now talk about PCA, like why we have to use PCA and all of this thing. Now devise some topic. So basically PCA means principal component analysis. So PCA is used to reduce your basically PCA is basically dimensionality reduction theorem. There are two types of dimensionality reduction. First one is feature selection, or we can say that feature extraction, and the second one is PCA, the dimensionality reduction. So in feature selection or extracts feature selection, in feature selection what we will do, we will find basically a covariance, or we can say it a correlation matrix. And whenever you will get a correlation greater than 90%, you will neglect these features. Basically they are not important, or you can apply some linear transformation, not no not done, directly remove these columns. But in PCA basically, firstly, this is a dimensional reduction basically. If you get, again you have to apply a PC algorithm. So in PC algorithm basically we apply a linear transformation by using eigenvalues. Firstly we have to create a vectors of that feature, and then we have to find out the eigenvalues, and according to that eigenvalues we have to find the eigenvectors. And whenever you are getting the higher eigenvalues and higher eigenvectors, like eigenvector module, we can say a magnitude, you will take this as a your dimension, like best fit variance. Like here you will get a very huge variance on that we can say a vector of values. So this is the projection algorithm we have to do. So in basically, suppose you are in basically PCA, what we have done, suppose there are three features, f1, f2, f3 is there, then we apply a linear transformation. So in linear transformation we will give some weightage to f1 and some weightage to f2 and some weightage to f3, and then apply, add, or basically multiply and divide. Something will be happened inside the PCA according to this eigenvalues. Now coming to the second topic, which is unsupervised machine learning algorithm. Wait 1 minute and let's continue our discussion on unsupervised machine learning algorithm. Ah, check the India, bro. Tejas, hi sir. Have doubt? Yeah. Ask. What's your doubt? You can ask me anything if you want. What's your doubt? Can I ask? Check the India. Otherwise, I am continue my discussion, or else you can ask. Okay. Low bias, high bias difference. Okay. Now, basically, bias means training error, and variance means testing error. So, if you training a model which have overfitted. Overfitting means your training accuracy is greater than 90%, but in testing accuracy is not good. Like testing accuracy is 80% or lower than training accuracy, like suppose 75 or 70%. So in that case, basically you have a low bias and high variance. Bias is referred to training loss and variance is referred to testing loss basically. So that's it. I think you will understand it. So low bias means basically you have a accuracy greater than 90% and high bias means you get a accuracy of training is lower than 80 or 70%. Okay, I think I have explained. If you have still doubt, you can ask. Tejas, how are you, bro? Understood, sir. Thank you. Mhm. So now let's continue our discussion on unsupervised machine learning. So basically we know that in supervised machine learning we have our training data set where we have a label data. Means suppose you are doing a house price prediction, then you have a label data like if this is the number of rooms and this is the location, then this is the price. But in case of unsupervised machine learning, we don't have a label data set. Label data set means you will not have a output column inside the unsupervised machine learning algorithm. So to solve this problem, we have some algorithms like K means clustering algorithms basically are there. So basically we have to solve this algorithm by clustering algorithms. So there are some algorithms like K-means clustering, hierarchical clustering, DB scan, Silvertay score. Basically Silvertay score is to find the accuracy of your model. So now let's see how K-means algorithm is done. So in K-means clustering algorithm, basically we have to create some cluster. Suppose this is your data set, this one. So basically we have to initialize our basically this point. So in k means clustering, basically firstly we will randomly initialize 2 points in the space anywhere you can initialize. So basically k is basically a hyperparameter, not it's not a predefined value. You have to think it like it's a hyperparameter you have to change at the time of training, like different k values. So to find this k value, there's some elbow method is there, I will let you know after some time. So basically you have to create some clusters, so and find the distances. And to find the distances, we have a Euclidean distance or Manhattan distance. Euclidean distance formula is basically, you know, that under root of x1 minus x2 square plus y1 minus y2 square. And Manhattan distance, basically this is a mode of x1 minus x2 into y plus y1 minus y2 का mode. So to start this algorithm k means clustering, we have to initialize some k centroid. Initially you don't know like how, what is the value of k. So initialize any random, suppose you have initialized 2, and then find the distances according to this formula. Suppose you have firstly initialize k, like first centroid here and here, and then find the distances, and then the whose point like distance is minimum, then this point will goes to this cluster, and this point will goes to this cluster. So according to this, in the second epoch, basically what we have done, take a average of this and then initialize as second basically centroid, and for this point again centroid, and again will be do until we will not get satisfied. We have to do run again and again this algorithm. So now the for by now the question will arise like how to find this case k value. So to find this k value, we have a elbow method, and to find this error of our model, we have WCSS, within cluster sum of square. So to find the WCSS value, basically suppose we have initialized k equal to 1 and this is our point, and then we have to find the distances. You can apply any distance formula, Euclidean, or you can apply Manhattan distance, and then this is your WCC score, WCSS score. And suppose if you apply k equal to 2, then again apply WCSS score, so you will get some score here. And this is the elbow method basically. So at the time, if you apply k equal to 1, you will get this WCSS score, and the 2 3 4 again and again you apply, you will get. But now the question arises, which k value I have to taken, like 4 5 6, because every time here you are getting some lower WCSS score than 4, but why we have to take 4 only? Because here only you are getting abrupt change means more change, but after 4 to 5 you have a less error. Like here you can see, if you see it's not a good change. So here we have to change, like take k equal to 4. That's how we have to take. And this is the formula to WCSS, distance between point to nearest centroid, and take the square. So basically this is the WCSS score. And Euclidean distance, Manhattan distance, I already tell you. Okay, so there is some you have learned about k means clustering, like there is also algorithm k means plus plus is also there. So they interview maybe ask like what is the difference between k means clustering and k means plus plus. So in k means, basically we have randomly initialized our centroid, but in k means plus plus, here also randomly initialized, but in k means plus plus, we want this centroid to be as far as they possible. Basically we have to initialize as far as they can possible, so that they will not merge. If you take some centroid nearer to us, then it will take some time to find the best cluster, and also you will not get a good accuracy. So they have this the algorithm like k means plus plus is there, which will help us to find, like initialize this k, like first centroid in a very far as possible. You can say this basically k means plus plus is a initialization technique, and in this algorithm basically we will initialize our first centroid as far as can possible. Now, hierarchical clustering. So in hierarchical clustering, same as k means clustering, but here we have to find a dendrogram. Basically this graph is known as dendrogram. This is the very complex diagram you can see. Can I teach you this, or let's continue our second algorithm? Okay, let's continue to hierarchical clustering. Basically, so in hierarchical clustering, basically you have seen this point P1, P2, P3, P4, P6. So firstly we have to connect, like create a cluster on P1 and P2 and connect on this diagram here, here, again, and in the second time like P1, P2, P3 is there, and create a circle on that, and then again connect P1, P2 into P3. So now how do I know like which is the best value, like k equal to 4, or like which k is very good? So to find this k value, you have to find here any point, like this is the main aim, like select the longest vertical line such that no horizontal line pass through it. So that means you have to find that longest vertical line. Suppose if you select this longest, suppose select this one, then this line will not be cutted by anywhere. Suppose you have taken this line, so this line will be cut by this line. You can see that if you take this vertical line, then this is the like horizontal line is cutting. If you take this line, then this line again is cutting, and this line is also cutting this line. So if you take this line, then this, and find and create this horizontal line. So here 1 and 2 cuts are there, so you know that k equal to 2 is the best fit point there. That's how we have calculated this k value. This is some complex algorithm. I think I have not explained a good manner because I am not able to draw some diagrams. If I will explain in a good manner, I think I will explain you, but you can, I think, understand basically this only. Firstly create a dendrogram according to circles on that point, and then only remember this line, select the longest vertical line such that the no longest line pass through it. Now continue hierarchical clustering. Now, okay, what is the difference between k-means and hierarchical clustering? Hierarchical clustering, variance of data, numerical data. Okay, so if your data size is very huge, then apply k-means clustering. Why? If your data set is small, then apply hierarchical clustering. The question is why? Because k-means clustering is a simple algorithm. So if your data set has a very huge data set, you can apply k-means. But if your data set is small, like hundred of thousands of rows is there, then you can apply hierarchical clustering, because here dendrogram is created, so you can't able to visualize in a good manner. So apply hierarchical clustering if your data set is small. This will give higher accuracy in case of this. Numerical data, number of clusters, centroid to find, elbow method, number of centroid, number of clusters. To find the number of centroid, basically number of points, we have elbow method. I have already told. To find the elbow method, we have to find WCSS score. Now Silbert score, like how, what is Silbert score? So Silbert score basically it's a d distance. Basically distance you can apply any Manhattan or Euclidean distance, you can apply any distance. I of j, I means basically your centroid point and j is basically these points are there. And the second formula is this is for a of I, if you want to find a of I. And to find b of I, basically b of I is basically you have to find distance from this cluster to this cluster. For this point you have to find distance, for this point again you have to find distance, all of this point, and you will get b of I. So now the question is what if our AI or BI is greater, like that I will tell you which is good model, like AI. Suppose AI or AI is greater than BI or BI is greater than AI, which model is good? So if your model has BI is greater than AI, then this is good, because suppose you are finding a distance within WCS scope, within the some within clusters, and again you have find a distance between another cluster, so the distance between another cluster is high. if you if your data set is giving a like lower distance another cluster and giving like low, what I can tell you, like suppose you have find a distance within cluster and again you have find a distance from another cluster. So if you get a distance from BI, basically BI is the distance from another cluster. So if you get higher distance from BI basically BI is greater than AI, then this is a good model. But if you have get a BI is less than AI, that means you have created some problems in your data set. This is not a good model. So that's how we have to know that. Now coming to DB scan, this is the best algorithm. DB scan, density based, some formula is there, name is there, I not remember the exact name. Basically density based CAN bit DB scan, full form, density based spatial clustering of application with noise. This is the name of the DB scan. So to apply a DB scan algorithm, you have to remember some points, like what is core points, what is border points, what is outliers, and what is min point, what is radius. Okay, so now let's start. Suppose take a one point, yellow point, and create a circle on that point. And epsilon is basically, we can say that a radius, and epsilon basically is a hyperparameter means you have to take different value of epsilon means radius and apply this DB scan algorithm. So here you will get a good accuracy. This is your epsilon value, and min point is also a hyperparameter. You have to change this also at the time of training your model. So now coming, what is core point, border point, and outliers? How to find this? So I said take this and create a circle of epsilon radius. So here you get a one point inside this circle. So this is your border point. So if you get any point inside that point, like here you will get one point. So this is your border point. Now take this as a center and create again circle of epsilon radius. So here you will get 1 2. 2 and 3 points inside that. So this is again a border point, like, but this is not a core point, because in the core point, if you have a greater than value min point, then this is a core point. So suppose you have created according to this point, uh, again circle 1 2 3, again you are getting 3 points. One, if you create this circle, then 1 2 3 again. So basically, if you create a circle, take this as a center and create a circle. So inside this circle, you can see that 1 2 and 3 4 points is coming. So this is your core point. Basically, core point means number of points within the epsilon radius be, and the numbers of points will be greater than 4, or we can say that min points. If you are getting core number of points greater than min point and the radius will be inside a radius, then this is a core point. If it is less than min points and greater than 1, then this is a border point. And if it is less than 1, here you can see that this point, blue point, this is the noise. Like if you create a circle on this, you will not get any point inside this circle. So basically this is the noise point. So this is the DB scan algorithm, which will works very good in case of if you have a noise data. So suppose in case of KNN, if you get some noise point, then your centroid will be shifted according to this noise point. But in case of DB scan, if you have a noise point in your data set, suppose some noise points are there, this will be neglected in DB scan. So this will, if your data set will have noise in your data set, then apply DB scan in case of unsupervised machine learning algorithm. This will be neglected. This will not affect, noise point will be not affected by your model in DB scan. So that's the basically advantage of applying a DB scan algorithm. Now again, I will tell you what is outer point, outlier, border point, and core points. Basically, core point means it basically greater than min point, like number of points will be greater than min points, and the radius will be epsilon. And epsilon and min points basically a hyperparameter. Basically, you have to, at the time of training, you have to change this and see like which giving the higher accuracy. According to this, you have to get this min point and epsilon. What is border point? So basically border point is basically if you have a point inside that, if you create a circle and you are getting number of points greater than 1 and less than min point, then this is your border point. And outlier is basically if you are not getting any point inside your this circle, then this is your noise point basically, and you have to neglect it. So here is the example of applying a DB scan algorithm. So here this is the k-means clustering algorithm example, and this is the DB scan. So in here in DB scan you can say that how it is created, like different colors it will be representing. So that's how it is working. DB scan is working very fine, and here is also like noise point is there and it will be neglected. But here you can see that it's it there, then this will go in another cluster. But here it will be neglected. If there is some noise points in between is coming, it will be neglected. So that's the benefit of DB scan algorithm. And that's it for today, guys. If you have some doubt, you can ask me. Now I will be closing my lecture. I have done all of this thing like DB unsupervised machine learning algorithm and decision tree today. That's it for today, guys. If you have some doubt, you can ask me now. Chat rate. Now I am closing my lecture. Ask me now. I think nobody have doubt. Okay,
Ask
let's
me
meet
now.
tomorrow. Thank you guys for watching my videos. Love you guys. Let's meet tomorrow.